Hello everyone and welcome back to another Geostats tutorial video. And in this video I want to walk through generating a semivariogram in R using the gstat package. So the first thing that I want to do is I wanted to get all of our packages and all of our data. So I'm copying, this is the same data set that we used in the previous two videos. It's the Fulmer data set that's provided from the gstat package. And then we're going to use the SP package to do our random sampling, which we actually don't specifically need for this particular video. So what we're going to do is we're just going to run gstat, and then we're going to get a fresh, clean copy of our data here. So what I want to do is I want to actually walk through the variogram function in the gstat package. So this is the gstat function. This is the function variogram from the gstat package. And I want to take a look at the arguments in specific objects and locations. So this is going to look very similar to the function call that we made in our IDW, except they're calling it object instead of formula. So what we're going to do is we're going to call the function var for variogram, and we're going to call it gstat : variogram. So again, instead of formula, we're calling it object, and then we need to have our locations, which is the data set. So again, just like before, even though we're calling it object, we're passing in that same sort of formula function of the name that we want, which is Fulmer. Again, this is the column name, not the data frame name. I know this is a little bit confusing. And then we're going to do a tilde1. This is saying generate the variogram based on the variable Fulmer. And then the data frame that we're going to pass it in, because it has spatial associated with it, we're passing it in as the locations parameter. This is going to be the spdf. Okay, and that's all we need for this. So if we run that, then we're going to plot var here. So this is our variogram. And what we need to remember with the variogram is there are three important pieces. There is the nugget, which is the semivariance at 0, which in this case I'm going to estimate to be about 3.9. I'm actually going to make some notes up here for us. So I'm going to call a nugget. It's going to be approximately 3. I'll go 3.7. Right? I'm estimating where this is going to hit the x-axis. It wants the sill. And the sill is the first maximum, so the place where it first peaks and then drops back down. Our sill, I'm going to say, if that's 8 and that's 10, I'm going to say our sill is approximately 10.1. And then we need to know the range. Okay, I'm interpreting the semivariogram, right? And so now we look for range. Right, that's the distance at which the sill occurs. And so our distance is going to be approximately 90,000, I would say. And again, it's not going to be perfect because we're reading a graph, but these are going to be pretty close to what we want. Okay. So the next thing that we need to do is we need to fit our empirical variogram, right, that's the thing that we actually got from the data, to a theoretical variogram. And our theoretical variogram is going to come again from the gstat package, but we're going to use a function called fitted, or fit dot variogram. Okay, so fit dot variogram, it takes in as parameters, there's two that we need to worry about: object and model. So this gets a little confusing, so I want to make sure you understand. So we're going to do fit underscore var, and we're going to call from the gstat package fit.variogram. So again, it takes an object, and then we want to take in model. So object in this case is not a formula like it was here. Instead, the object is literally the variogram that we just created. So we're going to pass in var. Right, we're now passing in this variogram object that was the result of this function. Model, this is going to be our best estimate of what we think the variogram should be. And we do that with a function called VGM. Right, so this literally generates a variogram model. So what does it take in as parameters? This takes in p-sil, which is our estimated sil. It takes in our range, which is our estimated range, and it takes in our nugget, which is our estimated nugget. So those are these three values that we already kind of estimated right here. And then it also takes in a model. And these are the four basic sort of default options for an estimated variogram. We have the exponential, the spherical, the Gaussian, and this is called the Mayturn. This MAT, this is the Mayturn. Now, all of these have slightly different shapes. Typically, you're going to want to go with one of the first three. I usually like to use Gaussian, so I'm going to use GAU. Oh, sorry. So we need to provide it a sil, the model type, range, and nugget. So what we're going to do is up here, we're going to then call gstat. Again, I'm just preferring so I know I'm pulling what I think I am, VGM. And in this, we pass in the p-sil, which is our estimated sil, which we said was 10.1. We pass in our nugget, which we said was approximately 3.7. We pass in our range, which we said was approximately 90,000. And then we pass in our model. And in this case, we're passing in that 3-letter code for Gaussian. So if we run this, what it's going to do is it's going to take our existing variogram, the information we've provided, and it's going to do a numeric analysis to fit this estimated variogram to our empirical variogram. So if we run this, you'll see that we didn't get any errors. Now what we can do is we can plot our original variogram, but now we can add in our empirical variogram, or our estimated variogram, by calling model equals fit var. If we run this, we scroll down here, you'll see that we've called our Gaussian. So this solid blue line here, this is our estimate, or yes, our estimated variogram. And you can see that it's done a reasonable-ish job. The closer to the points, obviously, the better. So it's done a reasonably okay job of trying to fit our data here. So that's how we deal with the variogram. And again, we have our nugget, we have our sil, and we have our range. And being able to first do the data-driven variogram, and then use fit.variogram to calculate the estimated variogram. This fit var is going to come into play in our next discussion on kriging. So hopefully this makes sense, and as always, please reach out. Thank you.